Okay, today we're going to talk about how we can transform formulas. Okay, another way of talking about this is how do we change the subject of formulas. All right, so let's go to the next page here. All right, let me pause. Okay, for example number 1, we're going to solve the distance equals rate times time formula for t. Now, what makes this a formula is that it's a special type of equation where these variables here mean something. This is distance equals rate times, and then the t is for time. So we're going to solve it for t. Now, in this equation, d is equal to r times t. R is attached to the t, so the first thing you want to do is you want to divide by r, okay? And on the left-hand side, you have t is equal to distance divided by rate. Okay, so that answers the first part of this question. Okay, now the second part of the question is use the answer obtained in part A. That was, let's see, that was time is equal to distance divided by rate. Okay, to find the time when the distance is 200 miles and the rate is 40 miles, and I actually forgot to write per hour. Right? So one way you could do it is just with numbers, all right? So you could say, okay, well, what is the time? Time is equal to 200 miles divided by 40 miles per hour, and that's 50, and time is measured in hours here. Okay, so that's your answer, 50 hours. Oh, sorry, nope, it should be 5 hours. It shouldn't be 50 hours. Okay, so that's 5 hours. That's one way to do it, but another way that you should be able to do is you should be able to keep track of the units here. With the 200 and the 40, I left out the units. So let's try this again, keeping the track of the units. Time is equal to 200 miles divided by 40 miles over 1 hour, right? That's what per hour means. It means I go 40 miles in 1 hour. Now, this object right here is called a compound fraction. It's a fraction that has another fraction embedded in it. So in the denominator of this fraction, there is another fraction, which is the rate, 40 miles per hour. So when we have a compound fraction, like if I had 3 divided by 1/2, I would keep the numerator the same. I would change the fraction, I'd change the division into multiplication, and I would take the reciprocal of the denominator. So the reciprocal of 1/2 is 2. Okay, so 3 divided by 1/2 is 6, because there are 6 1/2s in 3. We're going to do the same here. We're going to do 200 miles times the reciprocal of the denominator. So I have 1 hour over 40 miles. Okay, and so I'm going to put this thing that I'm multiplying by 1 hour over 40 miles is a whole number, so I'm going to put that over 1. Okay. Now, when I do this, this is called, I'm going to cancel out the units of miles, because I have a unit of miles in the numerator and I have 1 in the denominator, and I have the hours left. Okay, so I know that we can do it. Up here we did it with just numbers, so it's good that you're able to do it with just numbers. But you also, you know, the thing that I'm doing down here is I'm keeping track of the units, which you should be able to do as well, because pretty soon you're going to get to a science class where you need to keep track of the units in order to convert different units into other units. So it's good that we're taking this time to look at this. So we have 200 miles with the miles canceled with the miles in the denominator. So I have 200 times 1 hour, which would be 200 hours. On the bottom, I have 1 times 40. I have no unit in the bottom left, so I just have 40. And if I do out this division, 200 divided by 40 is that 5 hours that I got above. Okay, above, this is sort of, this one right here is the, I know it seems like it's easier, but when you're asked to convert something a little longer, you can't use this technique. Like if I asked you to convert kilometers per hour to feet per second, you'd have to keep track of the units like I did below. Okay, so you should have both things in your notes. Okay, example 2 is the volume of a cone is the volume is this formula right here. So the V stands for volume. Oops. The V stands for volume, so that's volume. This B, it's very important to note that that B is not base. That is base area. Okay, lowercase b is base. So if you had a parallelogram, you'd have two bases. All right, uppercase B is an area. That's a base area. And in this case, because it's a cone, our base area, the two-dimensional geometric object that makes up the base of a cone is a circle. And when I get the area of a circle, it's pi r squared. So in this case, the volume of a cone can also be written as volume is equal to 1/3 times pi r squared h, because that right there stands for big B. Okay, so you should pause the video and put this in your notes, and then I'm going to erase it so that I have some more space. Okay, so you should have that all in your notes. Right now I'm going to solve the formula for the variable h. So let's just rewrite the formula here. 1/3 base area times height. That's how you read that uppercase B. It's base area. All right, the things that I have on the same side as height are the 1/3. Another way, by the way, of writing this is base area times height divided by 3. Multiplying by 1/3 is the same as dividing by 3. Okay, so that actually might be a better way of writing it. Let's rewrite it that way. It's base area times height divided by 3. So if I'm solving for h here, the first thing that I want to do is I want to multiply each side by 3. Let's multiply this by 3. So I have 3v is equal to base area times height. Now I want to divide each side by base area. So I have height is equal to 3 times the volume divided by the base area. And I have solved for h. And I could have put h on the other side too. So I could have put h is equal to 3 times the volume divided by the base area. That's another way to write it. Okay, now we are using that information above. So we had solved for h. Height is equal to 3 times the volume divided by the base area. And we remember the big B stands for pi r squared, because the base of a cone is a circle, and the area of a circle is pi r squared. So they ask us to find the height if the volume is 92.0 cubic centimeters, and it has a circular base with a radius of 2.80 centimeters. So let's fill in that information. That's 3 times 92 divided by, now let's use the r in this formula, pi times 2.8 squared, right? Okay. 3 times 92 is, I'm going to use a calculator here, is 276. Okay, divided by pi, and I'll let you use a calculator at this point. Okay, so 276 divided by pi times 2.8 squared is going to be, and you want to round to the nearest tenth, so it's going to be 11.2, and that's in it's height, so it's in centimeters. Okay, 11.2 centimeters. Okay, and our last example, example 3, it says solve the temperature conversion formula for below for C. So this temperature converts Celsius. So I input Celsius temperature and I get out Fahrenheit temperature. So I want to solve it for C. So I want C on one side is equal to something involving Fahrenheit temperature. Okay. So first thing I want to do is I want to subtract 32 from both sides. Oops, it should be 32. So let's say I have F is equal to, I'll write it up here, F minus 32 is equal to 9/5 C. And I give a little space there because I want to be able to get rid of the 9/5. Now, in order to get rid of the 9/5, I want to multiply by the reciprocal, which is 5/9. Okay, so on the left-hand side, I want to multiply everything by 5/9. Now, make sure that you put parentheses there because you're multiplying the entire left-hand side by 5/9. And there are two terms on the left-hand side, not just Fahrenheit, but also the 32. All right, so 5/9 times 9/5 is 1. So you'd have 1C, which is just C. Okay, so I'm going to bring down the C. Is equal to, now you can keep it, the 5/9 on the outside, as long as you have parentheses. Or you could, if you want to, distribute it in. But for the sake of time, I'm just going to keep it on the outside. So this is how we convert Fahrenheit into Celsius. You could also have written it with the C on the other side. This is the reflexive property of the equal sign, is that I can switch everything else around the equal sign if I wanted to. Okay, that's another way to write the same thing. Okay, now if I were asked to find the Celsius temperature, if it is 90 degrees Fahrenheit, I could use the equation that I just solved for C above, right? And I would put in, I'd substitute 90 degrees in the Fahrenheit position. So I'd have 5/9 times 90, whoops, that should be 90. 90 minus 32, that's equal to Celsius. Okay, 90 minus 32 is 58, so I have Celsius is equal to 5/9 times 58. Okay, remember we put this over 1. So I do Celsius is equal to 5 times 58 divided by 9. Now 58 times 5 is 40, 25, 290. Did I do that? Okay. So we'd have 290 divided by 9. Okay, and so if I did that out, I'd have 9 goes into 290. Okay, 9 goes into 29 3 times. 27, that's 20. 9 goes into 20 twice, that's 18. I'd have 2, and actually I'm going to continue to get that, so it's going to be 32.2 repeating. 32.2 repeating, because 9 goes into 20, I'd get another 2, and I have a remainder of 2, so it's 32.2 repeating Celsius. That is my temperature. If it's 90 degrees Fahrenheit, it's 32.2 degrees repeating Celsius. If I rounded that to the nearest Celsius degree, it would be 32 Celsius. Okay, and that's the end of the notes for today.